Hello, students, and welcome to another screencast with Mr. Swan. This is today's topic is all about sunspots and really the sun in general. So it's quick. There will be about 2 slides we're just going to go through, and then I'll have you jump right on over into the web quest. Sunspots, just like the name implies, are spots on the sun. If you were to go and look at the sun with your eyes, you would say that hurts. I don't see anything. It's too bright. But what would really happen is if you're able to look at the sun with some type of mylar filter, which will block out a good majority of the sunlight, you would see that sometimes they look like little dots on the sun, like actual little spots, and that's where the name came from. Those spots to us look small, but if you were to zoom in and actually use a sense of scale to them, some spots can actually be just as big as the Earth. So they're quite large. And so this granular surface, that's all the sun. And then the sunspots are any of the part here that's a nice dark kind of black area. What is happening here? The sun works through convection, just like a lot of things in our world, that the hot plasma rises and then the cold plasma kind of sinks. They have different densities. The sun has a lot of magnetic fields. For Earth, we just have the 2 poles. For the sun, it ranges from hundreds to thousands. So they have so many of those magnetic fields actually disrupt convection actually happening in the interior of the sun, which then disrupts the place right here on the top part of the sphere of the sun, and that prevents convection from bringing up the nice hotter plasma. And so this area right here, the sunspot, is colder. If you were to touch it, it would still feel crazy hot, but it is colder than the surrounding area. And because things that have heat have electromagnetic energy, one thing they can get off visible light is that since this area is colder, it's not giving off the same amount as every other area. And so when you look at those 2 side by side, this area looks black. If you were to somehow are able to take the sunspot off of the sun and just put it out into space, it wouldn't look black anymore. It would look like a bright orange. So it's only because it is right next to an area that's way hotter than it by a couple thousand of Kelvin that it actually looks black. So it's not actually a true hole in the sun. If you were somehow able to walk on the surface, which you can't do because you would fall through or burn, that surface would still be there. It's just the color has changed. And so when you see that from 93 million miles away, it looks black to us. And so sunspots really have fascinated people for a long time. We have sunspot records that date back to pretty good ones from about 400 years ago, that people learned quite quickly, hey, there's these looks like little dots on the sun and they appear to move. Let's just look at them and count them. And we have been doing that for a long time to see if there's any type of a pattern to this. Does it do anything? Would it affect us over here at Earth? Does it affect the energy that gets radiated to us? And some of those things were yes, and some of those things were no. And on your web quest, you'll figure out which ones were yes and which ones were no. And that's pretty much what we're going to do today. The last slide, which doesn't exactly 100% relate, but I always feel like I should throw it in there somewhere. It's called the natural units of time. It is something that's not new to you. As soon as I tell you what it is that you have these pictures. Let's take a look at the one right here in the top right, where it shows half of an object is lit up with light and the other half is darkness. And let's just say this is the Earth. This object is spinning from this vantage point counterclockwise, and it just continues to go. So right here, pretty much at F, A, B, C, D, and E, they all have names to them. There would actually be an actual time, like 2 o'clock, 3 o'clock, 4 o'clock. But in this case, we give them different names. So we call those natural units of time. What are those names? Nothing new. So right here, when you have, let's start at E actually. So E is when your location is rotating right into the daylight. That is sunrise. So the beginning of the day, dawn. As it gets to about location D, we're still rotating through that light. We would call that, the morning. When it goes into C, you call that noon. And then eventually when it goes over into B, we call that maybe evening or afternoon. And then it goes into A. A is sunset. And then the opposite, and keeps on going. Now it's nighttime. It's getting all the way to about the middle of the night. And we call that midnight. So those are the names that we actually gave units of time for really thousands and thousands of years, long before we actually started using the numbers. number system. But it comes up every once in a while, and it's just something kind of good to know. And once you kind of see it, then I think you have a good idea. It's like, oh, well, E, this is when you go to school. This is, when you're in classes. C is right around when you have lunch. B is when you're leaving school. A is back when you're back home. Maybe you're doing some work over here before bed. Eventually you go to bed and you sleep right through a good majority of this. Then wake up and you start the day over again. How much time does that take? That is one solar day, also known as 24 hours. So the amount of time it takes for one point, let's say location C, to rotate all the way right on through, right to back to its same location with reference to the sun. So the direct rays are hitting that exact spot, the same angle as they were the day before. So we call that 24 hours or one solar day. The year, as we spin right around the sun, and orbit through our path through space, that takes 365.26 days. It doesn't hit exactly right on the whole number, but that's okay. Those extra quarter of a days, we take 4 of them, we add them up, and that is what becomes the leap year. So that's all I really wanted to talk about today. So a very, very short screencast. For your lab, which is it's a web quest really on the sun and sunspots. The one thing to kind of know about is on the second page, right on the top, talks about what does the sun look like. One part of that lab that I like to do is I like to take you outside to actually go look at the sun with some special safety equipment, so we can see it safely. I'm not there to do so today, so we will do that part when I come back. Looks like just based on the weather, looks like next week actually looks pretty sunny, so we'll probably do that sometime next week. All right. Thank you for listening. Have a great time. Learn a lot. And by the end of this, you really should make sure to also go to swanscience.com and take a look at the other lessons, lesson 1 and lesson 2 that you have listened to since I've been absent. Make sure you've gone through those websites. By now, the main goal is to understand sunspots, understand the phases of the moon, be able to list them, be able to draw them, and then I think it'll be pretty much okay. Eclipses, I think you guys will do pretty good with that. Okay, well, have a great time, and I will talk to you later. Goodbye.